So what's the frequency response in a microphone? Normally when they say a microphone is super good is because it has a flat frequency response. You don't want a microphone to color certain frequencies, because if it does, then it might be not suitable for all the jobs. Or conversely, many mics have a deliberate emphasis at certain frequencies which make them useful for some applications, like for example vocals in a live stage situation. In general, a problem with the frequency response are caused if you don't follow the directivity pattern or the directional response or the polar pattern of the microphone, and you are recording kind of offset. Classic example, you use a cardioid mic and you record it by singing or talking at the back of it. That's the classic use that we do in sound design for recording the voice of a person from behind the door. Self noise is also generated by the microphone itself. Condenser microphones are the ones that are most prone to create self noise because they have a preamplifier to amplify small signals that are produced by the capsules. Handling noise is also another factor, in particular in field recordings, while in a studio recording it should be fine. However, if you walk or the drummer of the stand is nearby some movement of the performer, you can have noise from there. What are the polar patterns? The polar patterns or directional response of a microphone is the way in which the microphone responds to sounds coming from different directions around it. It is determined more by the casing surrounding the microphone than by the type of transducer it uses. You can record the directional response of a microphone on a polar diagram, which shows the level of signal pickup, most of the time in decibels, from all angles and at different frequency ranges. It should be noted that all mics respond differently at different frequency. For example, a mic can be very directional at one frequency, usually the higher one, but virtually omnidirectional at another frequency. From the polar response pattern, one can determine the usefulness in different applications of the microphone, particularly in multi-microphone settings where proximity of sound source makes microphone leakage a problem. Typical patterns are four: omnidirectional, figure of eight, cardioid, and hypercardioid. The omnidirectional microphone picks up the sounds equally from all directions. Figure of eight microphones, bidirectional or figure eight, pick up almost equally in the front and the back, but nearly nothing on each side. It should be noted that the frequency response is usually a little better on the front side of the microphone, like brighter, although the level between the front and the rear are the same. Figure of eight, you use them when a high degree of rejection of frequencies is required because of the side's behavior. The cardioid microphone has a strong pickup on the axis in the front of the microphone, but reduced pickup off axis. This provides a more or less heart-shaped pattern, hence the name cardioid. The hypercardioid, you can change the number and size of the ports openings on the case, and you can increase the directionality of a microphone, so it even less sensitivity to sounds on the back and sides.